Thank you everyone for joining our session today. We're getting started with Mirantis K0S. That's new Kubernetes distribution that just arrived last year after November. I'm really excited to have tonight my guest of this time. He is a Jussi Nolans of Mirrors. He's a senior principal manager at Mirantis, and I'm really excited because he is also a tech lead for new Kubernetes distro K0S. Tonight we're exploring what, why, and how of K0S with Jesse, and hope you have enjoyed this session. And if you want to see more webinar on like this, you can ping me as on Twitter. Our Twitter handle is listing here in YouTube chat. You can send us an email or send us a tweet. We can figure out the what you are interested in watching our webinars. So we're really thankful Jesse for his time. So had to head over to Jesse.
All right, so welcome to talk about K0S, the new Kubernetes distro we've been working at Mirantis for a while. So I'm Jussi Nummelin. I'm working as a senior principal engineer at Mirantis. Been actually working with these cloud native technologies and things and stuff for the past 8+ years. Actually, even well before they were called cloud native and the whole CNCF wasn't even born yet when I've started to work with containers and related things. But I'm still kind of hard-headed and I'm still excited to build stuff and tools to help others take in these cloud native technologies and make people's lives easier with those. Standard legal disclaimers. So whatever I state, whatever features I mentioned on these slides, they're not like legally binding us to provide those features or anything. So the usual stuff. Maybe a couple of words about Mirantis, like what we do and why because as mentioned in the meeting meetup invitation, the kind of why we created K0. So Mirantis as a company has been working with different cloud and sort of technologies for past quite a few years and mainly to create technologies and create solutions to basically ship code faster, whether you're running on a public or private clouds. Of course, one of our kind of spearhead things is and has been the OpenStack, and of course that is something that we still strongly believe in, and the sort of marriage of Kubernetes and OpenStack, what we've been doing. And then of course the world of containers through the acquisition of Docker enterprise side of things and Kubernetes and everything. So that's our vision to sort of ship code faster with cloud native technologies and Kubernetes and containers. First things first. So K0S is the way to pronounce the project name. I mean, that's the official name or pronunciation. We actually even documented it in our documentation. You might hear me also saying it differently in different occasions. So there's nobody's gonna get you any troubles if you pronounce it differently. So don't worry about it. So K0S is something where we try to create a Kubernetes distribution that is like that simple to use, but of course we want it to be like fully certified Kubernetes distribution. So for those of you who are newer into the world of Kubernetes, so Kubernetes and CNCF maintains this sort of a conformance testing suite. So it's basically set of tests, automated tests that run on the cluster and figure out whether you are actually having a kind of solid and certified Kubernetes. Of course, it's not the first distro around, and it's actually not the first distro that I've been building myself and the team has been building. So we of course draw a lot of inspiration from other existing stuff, like for example a distribution called Pharos, which I've had my hands on in the past, K0S, which is of course a fantastic thing, and we draw some inspiration from there, and in the kind of K0S architecture and kind of concepts, there's some amount of similarities with K0S. Alpine Linux is one thing where we draw inspiration actually quite a bit. But of course, but at the same time, we have to acknowledge that we're really standing on the shoulders of giants in a way. So we wouldn't be of course doing K0s if there wasn't things like Kubernetes to start with. So we're really kind of standing on the shoulders of the open source giants. When we launched the publicly the K0S project in November, so after that we've actually had pretty good early traction. So looking purely from the GitHub, we actually see that we already have like more than 3,000 stargazers, and the binaries that we built have been downloaded more than 6,000 times already. So for us, although these are more like sort of a vanity metrics, but at least for us as the sort of core team and the core contributors of the project, this is something that kind of gives us a kind of signal that the K0s is doing something that there are use cases for, and people seem to like what we are doing and building. So that's a good thing, of course. So I'll kind of cover today like the basic questions for the project, that why in the first place would we create something like K0s. Then we'll dive a bit into like technical details, like what it is, and then of course how we build things. On the last parts of the slides, I'll of course then share a bit of the vision, like what are the next big things that we are planning to work on. No demo. Well, of course there's gonna be a demo, and of course it's a live demo, so be warned. So you know how live demos might go. So I might end up doing a live debugging session, but let's see how it goes. All right. So about the name. So why 0 in the name? So the 0 came from the sort of thinking that we wanna have like zero friction on the K0s. So we want to, and what I mean by friction is things that are adding complexity and kind of adding the small annoying things that you have to do when installing and setting up a Kubernetes cluster. So what we are trying to get at least is that there's like zero friction of getting you started with K0s and having a fully conformant Kubernetes cluster up and running. So you shouldn't have like 15 years of Linux experience in your pocket and another 7 years of Kubernetes experience in your pocket to be able to figure out how this works. Another zero is zero dependencies. So and this is something where I'll dive quite deeply in the presentation. So K0s is actually a single binary. So there's basically no host operating system dependencies. I mean on the kind of package level at least. It's actually not really zero at the moment because Kubernetes itself and some of the kube components they actually need a couple of other binaries on the system, but we're actually trying to get it to really to be zero, as we've actually done some upstream patches from our team to get rid of some of the external binary dependencies on Kubernetes itself. So basically you can ship the same binary into Red Hat or into Ubuntu or any of the Linux distros, and it works exactly the same way. And then of course zero cost. So K0s is it's an open source project. So with pretty kind of free to use Apache 2 license. Not pretty free to use, well, free to use, but Apache 2 is a good license to, so you can actually quite easily build your own solutions and project on top of that. So that's where the zero comes from on the name. Why? Well, what we kind of set out as a goal when we started to even think about K0s and what we'd actually need is something that we kind of started to think that we need versatility from a Kubernetes distro. And with that, what I mean is that we really have like very diverse set of use cases where we want and need to run Kubernetes today. I mean, it's not only us, but of course there's been many others like folks from Rancher and K0S world too that are seeing this kind of adoption of Kubernetes going towards the edge type of use cases also. So we need something that's like versatile enough so that you can deploy it on one hand, you can deploy it on your typical big cloud providers like Amazon's or on your private OpenStack or something. But then on the other hand, you have use cases where you want to deploy Kubernetes on the more like on smaller devices on closer to the edge of the network. And while doing that, our kind of thinking was that okay, yeah, we want to take Kubernetes into that world, but we want it to be like pure upstream Kubernetes. We don't want to maintain a fork of Kubernetes. I mean, maintaining a fork of something decent in size, and if you look at Kubernetes code base, it's a huge monster. So we definitely didn't want to start maintaining a fork of Kubernetes. In my past, I've been working with projects that provide packages for different operating systems like RPMs and DEPs and whatnots. And from that experience, I don't really want to do that anymore. Hence we settled for the single package, single binary packaging for K0s. And all this versatility and everything is of course not only about getting you a easy way to set up your Kubernetes cluster, but it also means that you have and we also have a base to build higher level solutions on top. So we have some ideas and plans how to utilize K0s ourselves, of course, and then hopefully you and the community, you have a lot of use cases where you can use K0s also. One of the biggest differentiators that we have in K0s compared to most other Kubernetes distros is something that we call as a control plane isolation. So in most of the Kubernetes distros, the control plane, the Kubernetes API, scheduler, and those components, they actually run on a node using containers and using kubelet on a node. So we actually wanted to have a way where there's no possibility for a user to schedule any workloads on a control nodes. And we'll dive also in this, but this is probably the biggest differentiator that we have in K0s. So by default, the control plane is fully isolated from the rest of the cluster, and that's pretty cool. And that actually is something that enables very versatile architecture for deployment. That actually gives us a nice bridge for a couple of terminology things. So control plane in the world of Kubernetes, of course, describes the nodes and set of nodes that run these Kubernetes management components like the APIs, schedulers, controller manager, and those. And a controller is a node that runs these control plane components. In the K0 world and in the documentation too, you might also see a term server being used. So we use actually these controllers and servers pretty interchangeably. We should really settle for one single term, and we actually have a GitHub issue even on that. So we need to settle down which one we use. Worker plane. So that's of course the set of machines running the user workloads, of course, in containers with the help of some Kubernetes components. And a worker is a single node that runs these container workloads. All right. So in the architecture of K0s, so I mean, you with K0s you still get Kubernetes. So of course the architecture is pretty much what Kubernetes architecture is. So you have your Kubernetes components like API, scheduler, controller manager, whatnot. And then on the worker plane, you have your nodes that are running kubelet and kube proxies and some other components. Yes, of course. It's still a standard and conformant Kubernetes setup. But of course, what you have in K0S is that everything, all the Kubernetes components and plus something else, they are packaged as a single binary. And all of the Kubernetes components are sort of managed by K0S itself. So you as a user, you don't really have to worry and figure out how to manage like Kubernetes API components or anything. You just have to start K0S and the K0S itself will actually then manage your Kubernetes API components. As I already mentioned, so all of the Kubernetes stuff that we bundle in is 100% upstream stuff. So we don't do and maintain any forks of Kubernetes or any of the related components. If we need to fix something, we push it to upstream. So what it actually means for us is that we can actually adapt to upstream changes pretty fast. So whenever there's a new version of Kubernetes out there, it's like a couple of days and we have it packaged in K0s. Usually it's nothing more than that. It's actually not a Kubernetes versioning example, but one example was one of these containerd patches. So there was a CVE like a month, 2 months ago, can't remember anymore, on containerd and it was actually less than 24 hours after the CVE was announced that we had a new package of K0s out there with the fixes on that. So working with pure upstream and it really allows us to focus on the K0's parts of the solution, so that we don't really have to spend and waste effort on maintaining a fork. So yeah, everything in K0s is packaged as a single binary. So one way to think about it is like it's kind of like a self-extracting binary. So what's actually happened or in the binary, so there's actually other binaries within the K0's binary. All of the binaries that we package in, like all of the Kubernetes components and everything, we do compile them in our build pipelines. So, but the source for those builds are of course fully upstream sources. But we do the compilation as we want to have fully statically compiled binaries. What it means that the same binary can actually work between different operating systems, like or Linux distros, for example. So you can use the same binary then with Red Hat and with Ubuntu and whatnot. Of course, for Windows we have two different builds, but that's another discussion. So we don't really have to maintain all the deps and RPMs and whatnot. So if you ever had to work on those sort of Linux distro packaging issues, it's although it sounds like a simple thing, but it's actually actually quite a lot of work to make everything work with different versions of Debians and RPMs and whatnots. So in the end, we have a single binary that's easy to ship around. So if you want to set up your cluster, just dump this single binary into all of the nodes and you're ready to go. One way to think about K0S is, of course, also like it's a like a glorified process manager. So all the Kubernetes components and all other dependencies like containerd, kubelet, everything, we run those as what we call like naked processes, or so like just like plain processes, no containers in the picture in that sense. So what it allows us is to run the K0S components and controllers, for example, in environments where you actually can't run containers. There's less dependencies, so you don't have to have container runtime on all of the controller nodes, for example, and so on. It also allows us to slightly at least tighten the security. So what we actually try to do in K0s or what K0s tries to do is that it if there are different users set up on the Linux system for different components, so it'll actually bootstrap the Kubernetes components and run the processes as a different users. So not everything is run as a root. On the control plane, there's no container runtime, there's no kubelet, there's no containers running by default. So what it really means is that you as a Kubernetes user, you don't really have any way to schedule your workloads into the controller nodes, whether on purpose or by accident. That's actually something that's like in most of the Kubernetes distros. It's like really hard to control that who can actually schedule workloads on which of the nodes in the cluster. So that's although Kubernetes are back the role-based access controls, they are quite strong, but that's something that's not like really easily controllable by the RBAC or anything. And as I mentioned many times, and I'm mentioning this because this is the main thing that differentiates K0s from other solutions, is that this control plane isolation really gives you a lot of versatility on your deployment options. So with this, you actually can run your control plane, say on a public cloud, and then you can actually run your worker plane on your private data center behind firewalls and everything. So that's now doable with this sort of a control plane isolation. One of the sort of mottos that we have on the K0S team is that battery is included but swappable. So although we have defaults and we provide most of the things out of box, there are ways for the users to swap things out. So by default we ship with containerd as the container runtime, but you can of course use K0s with your own container runtime implementation. So whether that's Mirantis container runtime, the what was previously called Docker Enterprise, whether you use the Docker Community Edition or Creo or whatever. So as long as it's compliant with the CRI interfaces and definitions, then you can use it with K0s too. But of course, then it's up to you to ship the binaries and the packages and whatnot. Same goes for the CNI, the container network implementation. So the networking implementation on your Kubernetes cluster. So by default, we ship with Calico as the CNI implementation. But of course, you can configure K0s to not set up Calico and do the CNI configuration yourself. You can of course bring your container storage implementation into the cluster. So we don't actually ship K0s by default with any storage provider. So we made the choice, at least for now, to not ship with any storage provider, because there are so many providers out there, and there are a lot of differences in the providers. So one provider is good for one use case and the other one is good for another use case. So we can't really make a choice in K0s which one we should bundle in. Thanks to the open source project and component called Kine that originates from the folks on Rancher and K0S. So we also embed Kine into K0s, and with Kine you can actually swap out the default etcd storage on the control plane to something like MySQL or any compatible, or Postgres or SQLite for single node cases. That again is something that allows versatility on the deployment options. So if you don't want to have pain with etcd, you can use something like hosted MySQL or Aurora or whatever compatible database from your cloud provider, for example, as the sort of backend for the control plane stuff. So Kine is really fantastic on that. Okay, let's dive into some of the details that how we actually implement it before we dive into live demo. So single binary again. How we actually do it is that we when we build K0s, we actually build the binary as a more like a temp file first. And then at the build time, we actually generate these sort of offset positions for different binaries. So say that we embed like a kubelet binary into K0s binary. So we basically know, of course, the size of the kubelet binary, and based on that we can actually calculate the offset position for the kubelet within K0s binary. And then we actually add that information into the K0s binary itself, and then during runtime we can then kind of easily seek and extract the binaries out from the K0s binary. So sort of like a self-extracting, well, not sort of, it is a self-extracting binary. And for those of you who've been working with Golang stuff, so there are a lot of different solutions how to embed embed some content into your binaries, whether that's another binaries like in our use case, or whether that's like static websites or anything. But most of the existing solutions, they had a problem that the data is actually embedded as Golang variables, and what it means is that they are actually loaded into memory. So when we use those, we saw that, okay, yeah, although this is nice and fine and everything, it works perfectly almost, but it ended up having a lot of things loaded in memory, which we don't need. Of course, we don't need the kubelet binary in memory all the time, on the K0s process at least. And yeah, everything is statically linked, so there's no like OS dependencies on the package levels and or anything. So you can use the single binary on any of the Linux distros. But the control plane now isolated from the worker plane. So Kubernetes has a less known concept called egress selector. So if you configure your control plane components, mainly the API server, if you configure it to use this egress selector concept, so what it actually tells to the Kubernetes API that okay, whenever you need to call something that's outside from from the API perspective, the call is actually made to this egress selector. So it's basically acts as a sort of proxy of sorts. So whenever the API needs to call something external, whether it's some external API or whether it's a node or kubelet API, what typically is, the API makes the call actually to this egress selector, which is a proxy of sorts. And now on the worker plane, we actually set up a component called connectivity agent as a daemon set. So it's basically running on each of the nodes. So the agent itself is configured to call home. So the agent actually opens up a socket connection to this connectivity server. And this connectivity server is now this egress selector, or configured as this egress selector. So what actually happens when the API server needs to connect to the worker node to get some information, or if you're getting logs of your pods or executing yourself into a pod, those are the things where you actually have to, where the API has to connect to the kubelet running on the node. So on those cases, the API server sees that okay, I have to use this egress thing because I'm configured to use that, and it actually calls the connectivity server, and the connectivity server figures out that okay, we're targeting a node, this specific node in the cluster, and it sees that okay, I have an open socket opened by the agent itself. So it actually uses this sort of reverse tunnel to connect to the node. So what it actually means now that you really can have firewalls with only outbound access in front of the worker nodes. So this way I can really run my control plane now, for example, in a cloud, and I can run the workers in my private data center, or I can simulate a private or emulate a private data center on my Mac using virtual machines or containers or whatnot. So this is something cool. I know K0S does similar thing, but they actually do it a bit differently technically, and that this, as far as I know at least, this is one of the reasons why they've actually had to do a fork for Kubernetes to inject these sort of functionalities. As far as I know, I might be wrong, which is not a new thing for me, but we do this with like standard Kubernetes configurations, and this connectivity server is one of the Kubernetes, especially in their infrastructure 6 projects that we are using and hopefully contributing also in the future. Joining new nodes, and this is something that I'll demo. So we use these sort of tokens to sort of authenticate the join process in the between the nodes. Let's see if I'm able to demo it, but the tokens are actually valid kube configs that are used for different components like kubelet, for example. And we use that tokens both for worker and controller joins. So of course, worker join is like connecting the kubelet and node components on the nodes to the control plane components, and when we are running join process for the controllers, what we actually do is we need to sync up things like the CA, the certificate authority created for the cluster. We need to, if we are using etcd as the data store for the control plane, then we also have to reconfigure etcd to have a new members in the cluster and whatnot. So that's also handled dynamically by K0S. There's two ways to sort of extend the out-of-box experience with K0S. So we have this sort of a manifest bundle functionality. So there's a special directory on the hosts where you can actually create subdirectories and dump your custom manifests in, and they will be loaded automatically. So say that you want to ship with your own CNI, let's say we, for example, just drop all your manifests into that folder and they will get applied automatically. Another way is to do these extensions as Helm charts. So in K0S YAML configuration, you said that, okay, we want to use these repositories for the charts, and then we want to install these charts with these values. And then when K0S bootstraps, it actually then applies and set up these Helm charts for you automatically. So you have a sort of one place where you control your kind of base cluster features, what you want to provide for your users, if you're running this sort of a platform for your developer teams, for example. And yes, we do support Windows. So we have marked Windows support as highly experimental. We know that there are some super rough edges on K0S. There's some rough edges still. We know that they are there. But for Windows, there's even few more of those that we need. And one of the things that we are trying to work out is the dependency on existing Docker or Mirantis container runtime on Windows. So currently you can use K0S only when you already install Docker or MCR on your Windows nodes. We were planning to ship with embedded container D also for Windows, but there seems that there's actually a container D. I'm not sure whether to call it bug or a feature that renders it not so usable, or it doesn't actually work with the CNI providers. So we're actually having a bit of trouble figuring out how to make that happen. But basically, the user experience is pretty much the same for Windows workers also. So you run the worker stuff, give it a path to the Docker socket, and basically that's it. So that's pretty neat that you have almost the same user experience on Windows workers too when joining the Windows nodes into the cluster. Okay, quick words about the what we're planning to do in the near future before running a super quick demo. So we're targeting a sort of release per month kind of release cadence. We are hoping to get the 1.0 release out on the first half of the year. And then we of course do batch releases then whenever needed, whenever there's a bug critical enough to be fixed quickly, or whether there's some bad CV on some of the Kubernetes or other components or things like that. We are hoping to get another release out still during this month, well, with some dual stack IPv4, IPv6 functionality. Windows work with plain containerd, well, as said, probably not going to happen during January. There's going to be a few more Calico customization options. And then we are actually coming out with another tool called K0S CTL to allow you to build your multi-node kind of lifecycle manager for multi-node K0S clusters. Then of course a lot of bug fixes. Then for the near future, we are planning to work on to support like fully air-gapped environments, built-in functionalities for backup restore use cases. Then of course Kubernetes is gonna come out with 1.21 series of releases in next couple of months. Pre-shared joint tokens to make life easier for cases like auto-scaling clusters and those sort of things. There's been some discussions. People seem to need or want to have like pre-built virtual machine images for K0s. And then of course we are thinking of, and we know a few places where we need to optimize things quite a bit actually. So that's something that's in our radar. But of course it's an open source project, so you as a community, you have of course a saying also what you need and what you want to have. So just open the issues and enhancement requests on what we can do about it. And of course, even better if you open pull requests directly. We have documents up and running on docs.k0sproject.io. There's of course the GitHub repo, a lot of information there. And then we are sharing the Slack channel on our kind of neighboring team with the Lens. So on the Lens Slack there's a dedicated K0 channel. So join that Slack and join the K0 channel to have a chat with people. Okay, I'm running quite late on the schedule, but I'll run a super quick demo on things. So for the demo, I'm just applying some Terraform stuff just to create me a couple of test boxes on Hedgener cloud provider. Should have done this before because it takes a couple of minutes. So the Terraform stuff is nothing special. So there's just controllers, there's just workers, they are just small virtual machines. And what I've done is that it actually runs a script to get me the K0S binary in place as part of the provisioning. So I'm using for the demo, I'm using the beta 1 release of the 0.10 series. So well, as the version implies, so it's beta. So hopefully it'll actually work. I just wanted to use the beta because it has nice enhancements on the installation of K0. So and of course for production use cases, you shouldn't really like curl and pipe it to execution like this. So of course that's a known security things, so don't do this in production for demo purposes only. Still creating, okay.
अरुण बाहर जा यार.
Done soon. Okay, I see one of the nodes completed. It usually doesn't take this long. What did I say about the live demos? How good idea is it? It is. Okay. I did try this actually last night, so and it did work perfectly, but well, the gods of computers are not with me today, it seems. Still creating, okay. It usually finishes up around 1 minute and 30 seconds. Okay, it actually did finish. Okay, so basically I have now 4 boxes on my hands. One of them I'll use as a controller, and rest are actually workers. So SSH root and this IP, yeah, I trust it. K0S version, yeah, the binary is in place. So one of the enhancements that's coming in 110 is this install command. So what I'll do, because this is the controller, also known as a server, so I want to actually install the server parts. So what it actually does for me, it actually creates all these users for different kube components and processes, and it installs K0S as a systemd service, because this is an Ubuntu box, so there's systemd available. So what I can do next is systemctl start K0S server service. Voila. And in a few minutes, you'll see that there's the K0S server by process running, and it actually manages all the etcds, APS servers, everything for me. All right. Let's connect lens into the picture. So cat for lib K0S PKI admin conf. So this is the administrator kube config. It's long as hell, but I have my lens dashboard IDE running, paste in the config, and then of course I have to change the local host address to whatever was the controller's IP address. Add cluster. Voila. We can see that of course for the workloads, they're all pending because there's no workers connected to the cluster yet. So you see that the controllers don't really run any of the workloads. So let's connect at least one worker into the cluster. SSH root at yeah, I trust it. And then to be able to join a worker node into the cluster, I need a token. So something that I can sort of authenticate the worker so that it's actually allowed to connect to the cluster. For that I need to first create the token. So of course, so K0S token create role worker. So this actually creates me a super long token that I can use as the way to authenticate the worker into the cluster. So I'll actually add that or create a file called K0S token with just the token in it. And then what I'll do, I'll again install. I want to have the systemd services for K0s, so whenever the node boots, the K0s part will actually boot also with it. So K0s install worker. I get the token file from /root K0 token. Of course, you have better places to put these sort of files in, but yeah, it's now here, and that's it. Installed as a service, and then systemctl start K0s worker service. And in a minute or two, we'll see that we actually get a node on the cluster on the lens. Yeah, worker 0 connected. Of course, it takes a while until it actually gets like in the ready state. It needs to pull out all the images for Calico and whatnot. And then I could do the same process, repeat and rinse and repeat for all the nodes, but the process is exactly the same. Just get the token in one way or another into the nodes, and then run the worker with the token, and you have everything set up. Yep, node ready. Conditions ready. Some of the pods are still being created. Okay, all of the pods are now created on the node. Yep, everything's green. Everything works out of the box, and then you can of course scale the number of worker nodes as basically as much as you need. Here on after it's standard Kubernetes, so use Lens or use any of your Kubernetes tools to connect to the cluster and be done with it. All right.
So
that's K0.
Thanks, Jussi. It's been a very thoughtful about session. For me as a presenter, as a host, I learned a lot of cool stuffs. So before the session, I have a confusion around how to compare with the K3S with the K0S, how it's pointed, how it's implemented, how it's configured, how it's used. During this discussion, I learned all of very cool stuff. Why part of it, what part of it, how part of it. It's been a very exciting session for me. But I have included some question from audience previously in my email box. So one of the question is that in a K0S cluster, we are using a systemctl services rather than a static pod or any other way of configuring the bootstrap, configuring the control plane components.
You mean why we are using?
Yes. Yeah.
Okay. So yeah, that is basically coming from the fact that we want to have the control plane stuff isolated from the cluster. So we on the controller node. So if I go to this controller node that I created, so if I use this standard PS4, for example, you'll see that the K0S server process, when it starts, it actually creates and spawns and manages these other components as plain Linux processes. So we don't have, I don't have any containerd, I don't have any Docker or anything running on kubelet or anything running on this controller node. And this really means that I don't have any way as a user. I mean, if I go to my Lens, if I go to my nodes, I don't see the controller as part of the cluster. It's not something where I can actually schedule my workloads on. So the control plane is now fully isolated from the cluster and from the workloads. I mean, from scheduling perspective. And that's why we do this in the way we do it, without kubelet containerd container runtimes.
Yes. Okay, got it. But the next question on this topic of, so if there are some distros of Linux where systems D services are not available, so if I use a K0S cluster, so I need a operating system with the Linux system D services already configured.
No, you don't need it.
Okay.
You don't need it. The K0S install, this K0S install, yada yada yada. The install command is actually able to figure out whether you have systemd in place or not, and it also supports this OpenRC, which is used also, for example, in Alpine Linux. So it can actually inject this system service as an OpenRC service too. But even if you're running something exotic that doesn't have either systemd or OpenRC in, it doesn't matter how you start the K0S process. So what I could actually do is I can actually do like systemctl stop K0 service, which will then of course stop all the control plane components. So I don't have any etcds or anything running anymore. I can run the K0 server as a plain process on my foreground. So we don't have like any hard dependencies on systemd or anything.
Okay, so number one, if you have a system where systemd services are not available, so K0S can set it up in the K0S as a systemd services, and also it has not a pretty much hard dependency of systemd services to run their management control plane. So
yep.
Okay.
Yep. It's just up to you then to figure out how to get it started when the computer starts.
Okay, and also we have a single binary. We don't need to be expert on RPM or depth dependency or arcade or any other stuff. It's a single binary. You just run the K0S install command, and it's put in this. It's extracted the single binary and and wrap the whole API server, controller manager, etcd, and also all kind of things. Just using a single binary.
Yes. So when you've started the K0S stuff, what you'll see is underbar lib K0s, and this is of course the path which we use as the data directory is of course configurable, but there's a folder called or directory called bin, and you'll see that we actually extract all these kube components, these kube binaries there.
Okay, and also it's have a same opinion about like a rancher had, so extracted the different composition of data plane server, like storing the etcd, where you can swappable with SQLite or DSQL any way you want. There's a kind project already is there, the server you can swap or pluggable, and
yes.
And for the storage right now you are using the CNI for Calico, but it's completely pluggable whatever you want to use.
Yes. So if we do this K0's default config, let's pipe it to a YAML file. I hate the fact that the Golang YAML serialization does everything in alphanumeric order, because it's not the logical order how people usually see things. So for example, for the storage, you can configure. By default we use type etcd, but of course you can also configure coin and with the MySQL or SQLite backends or whatever. And then for the network, by default we use Calico as the provider, and then we have some default configuration for Calico. But of course, you can say that, okay, we are going to use a custom provider. That means to K0s that okay, K0s will not configure Calico in any way for the cluster. So it's fully up to you then to configure whatever CNI you want to use in the cluster. You could use Weave or Flannel or anything else, Multus or whatnot.
Okay, so actually, I think Calico is a very good choice because Calico is in this space of CNI doing tremendous stuff like the extended ABF support and cool kind of. So by default, Calico is a choice for many of the people. But you
Yeah.
use Cilium, VaveNet, Flannel, or any other as you need it to be. So next question is, so it's do K0S have a support for integration with the cloud providers right now, in plan or in progress, or do you we can see in the future if already not have?
We already do support that. So for that you need to configure the worker with let me grab a connection to another worker node. I can't remember the name. Worker help. Yeah, for the worker you need to add this enable cloud provider flag. So that'll basically tell kubelet, or it basically adds the cloud provider flag to kubelet. We don't support any of the sort of Kubernetes in cloud providers, so you always have to then deploy the cloud provider support as pods in the cluster, which is the recommended way nowadays anyway to do it. So we don't add these Amazons, or we actually compile the Kubernetes components without the cloud providers in them currently.
Okay, and one last thing, if one of the node, like let's say we have a controller manager there, they are here in my laptop, and the cloud providers, the worker nodes are in the Azure or AWS or GCP. So some of the node in the workers are in the GCP, some of the workers are in Azure or AWS, because they have hybrids. The people have their opinions, have use cases around hybrid cloud provider, and they want to manage their workload out there. So currently, is that the scope of project, or?
Well, if the let's put it this way. So K0s doesn't have K0s, and we as the project, we don't have any strong opinions on any of the cloud providers. So you're of course free to use whatever you want, but if you want to have the same cluster kind of spanning between different or many cloud providers, you'll probably actually see a lot of troubles on the networking part. So you might have a hard time connecting the nodes between different cloud providers into the same cluster. That's just kind of a limitation on the networking, at least partially. You might be able to come around those, or at least some of those issues by using what we have also configurable on Calico, this WireGuard. So that might get you out from some of the troubles. But then I have to be honest, I haven't tried to run Kubernetes in a way that I've actually then also enabled the cloud provider integrations for different clouds in the same cluster. I'm not actually sure if that's even possible.
Okay.
Because then you'd have competing stuff for different, like for things like let's say that I create a service type of load balancer. So who actually implements the load balancer now? Is it Google or is it Amazon? I don't know. So I'm not sure whether having multiple cloud providers configured in the same cluster actually can even work. Probably not.
Okay. So for K0S, we can run it on Windows and Linux as well. Is it?
Yes.
Uh,
But on Windows we only support the worker parts.
Okay, worker bars. For the
Yes.
control pane part, this all you have to have a Linux or virtual machine somewhere, so you manage the cluster for yourself. And
Yes.
if right now, as a I am beginner tool, I see Kubernetes API server, controller manager, scheduler, etc. So is anything new in the K0S cluster, or is going to be it's going to be a super replica of the upstream Kubernetes?
It's a full upstream Kubernetes. So I mean, what you get is still you get Kubernetes. So we don't change the fact or hide the fact that it's Kubernetes. So or we don't build fancy layers on top of it or anything. So it's Kubernetes. But as you saw, it's like that simple to get your Kubernetes, and you don't have to figure out different like different packages that you need and have dependencies between packages and whatnot. So
Okay. So it's just write a single command K0 install, K0 install and service, and you have all the one binaries extracted, all the major components of Kubernetes, and they have already installed in your system. You doesn't have to be expert of dependency management packages or host dependency packages, and you have also support for different CRIs, CNIs, CSIs, and also have a relatively closer to the, or together it's a really close to the upstream cluster. So anything is changed there is going to be seen in the K0S immediately, because it's not a fork repo and you are not maintaining the fork repo. It's a super upstream Kubernetes.
yes, exactly.
And also there are distribution around micro K8s, kubeadm, K3s, and many other. So you have learned the great things from there. And also you see the some use cases where they are not fit together, and you have put together effort to fill those gaps in your K0S project, where K3s is not meant to be feasible or micro 8s is not feasible. So because micro K8s is not feasible where you have doesn't system D configured, so you are not so much dependent on system D services. And if their system D services are not installed in operating system, you are using the system some ways up to install system D and run K0S on the system where system D services are already not installed.
We don't install system D services. So as said, we don't have any hard dependencies on system D at all. So if your system has system D, like most of the Linux distros do have, yes, then K0S, it kind of injects itself as a system D unit. But as said, you are fully free to run K0S in whatever way you can bootstrap the process, whether it's a startup script of your own, or whether you do it manually each time the computer reboots, or we don't really, whether you do it with cron tab or anything, it doesn't matter matter to K0s how you do it. As long as we start the K0 server process, and that's it. We don't K0 doesn't really, and we don't care how you do it. The installation as a systemd service is that's just like a helper function, so that you don't have to type in your like full service definition. System K0s. So this is essentially what the K0s install does. It creates this systemd service stub or service unit, and that's it.
Okay, so kind to wrap this every questions up. So for the it's we learn from some things from micro and other distribution and fill those gaps in. So kind of to summarize, if I want you to summarize how it's similar and different to different case different distribution, to how you summarize is in a few minutes or few words.
Okay, so I've kind of intentionally tried to avoid like really comparing things with different distros, because the distros are different. So it's like comparing with like bananas to apples or something. So I mean, there's use cases for different distros in different places and those sort of things. But the main difference in K0s compared to others is the fact that the control plane is isolated. So and that allows versatility on the sort of deployment architecture of K0s, and that was the probably the main thing that kind of led us to create the K0s in the first place.
Okay, that's thanks to wrapping up. It's been a very exciting session for me, and hopefully everybody enjoy afterward, learn some of the cool stuff from you, and really appreciated the time and efforts of you and K0S team for presenting their talks with us, so we can understand the motivation, what, why, and hows of K0S, and how to learn this. And we are really excited your time for in with us. We hope to see you in future as well. But all the good wishes for your project, all the good wishes to K0S team. So happy you can do some good stuff, and hopefully everybody watching this session enjoy the time spending with us. Thank you, Jussi. Thank you, Mirantis, for at the team for conducting our session with me, and thank you, K0S, for showing your energy and time and knowledge with that. Thank you, everyone. Bye bye, Jussi. Bye bye.
Thanks.